Hey everybody, in this video, we're going to be learning about volumes of revolution, specifically the washer method. Here's the big idea. We're going to take the area between two curves and rotate that around the x-axis to form a solid of revolution. In order to do this, we're going to rotate rectangular strips in the shaded region around the x-axis to form washers, which are thin circular slices with inner circles removed. Each washer has an outer radius and an inner radius. Let's call the outer radius f of x and the inner radius g of x, and the thickness of each washer dx. Now we can find the volume of one washer. Let's call that dv. dv equals pi big R squared minus pi little r squared, all times dx, the thickness of the washer. Now we can factor out the pi and substitute f of x for big R and g of x for little r, and we get pi times the quantity of f of x squared minus g of x squared dx. Now the volume of the entire solid is the sum of the volumes of an infinite number of washers on the interval AB. And we can use an integral to find this. V equals pi times the integral from a to b of f of x squared minus g of x squared dx. Let's do an example problem. Set up the integral that represents the volume of the solid formed by rotating the region between f of x equals x squared plus 1 and g of x equals negative x plus 3 around the x-axis on the interval 0, 2. First, we need to find the outer radius, which we'll call big R. Big R equals f of x, which is negative x plus 3. Then we need to find the inner radius, which is little r, and that's just g of x, which is x squared plus 1. Then we can find the volume of one washer, which is dv. And dv equals pi times the quantity of negative x plus 3 squared minus x squared plus 1 squared, all times dx. Then to find the volume of revolution, we just need to find the sum of the volumes of an infinite number of washers on the interval 0, 2. And the integral lets us do this. So this means we have pi times the integral from 0 to 2 of negative x plus 3 squared minus x squared plus 1 squared, all times dx. This integral represents the volume of the solid of revolution of the region between negative x plus 3 and x squared plus 1 rotated around the x-axis on the interval 0, 2. Now, let's look at how to use the washer method to find the volume of a solid of revolution rotated around the y-axis. Just like I discussed in the previous example, we're going to take the region between two curves, but this time we're going to rotate it around the y-axis. The way we're going to do this is by rotating rectangular strips within the shaded region around the y-axis to form washers. For each washer, we'll call the outer radius f of y and the inner radius g of y. The thickness is dy. Now we can find the volume of one washer, which we'll call dv. And dv equals the quantity of pi big R squared minus pi little r squared times dy. Then we can factor out pi and substitute f of y for big R and g of y for little r, and that gives us pi times the quantity of f of y squared minus g of y squared, all times dy. The volume of the entire solid is the sum of the volumes of an infinite number of washers on the interval AB, and we can find this by using integration. That means v equals pi times the integral from a to b of f of y squared minus g of y squared, all times dy. Let's do an example problem. Set up the integral that represents the volume of the solid formed by rotating the region in quadrant 1 bound by y equals x squared and x equals 3 around the y-axis. Here we have a diagram of the region described by the problem. Note that y equals x squared needs to be converted to x equals radical y. Now we can determine an outer radius and inner radius. The outer radius, big R, which we'll call f of y, is 3. The inner radius, g of y, is radical y. Now we can find dv, the volume of one washer, and that's pi times the quantity of 3 squared minus radical y squared times dy. That means the volume of the entire solid is pi times the integral from 0 to 9 of 3 squared minus radical y squared, all times dy. Note that the limits of integration are y values now. We're starting at 0 and adding up the volumes of all the washers that are stacked until they reach 9. When x equals 3, y equals 3 squared, which is 9, and that gives us the upper limit of integration. So let's recap. When rotating a region between two functions around an axis, you need to use washers. When rotating around the x-axis, we'll use pi times the integral from a to b of f of x squared minus g of x squared dx. Note that the limits of integration, a and b, are x values. When rotating a region between two curves around the y-axis, you can find the volume of revolution by using this, pi times the integral from a to b of f of y squared minus g of y squared times dy. And note that a and b, the limits of integration, are now y values. Make sure that you practice many different problems so that you truly understand when and how to use the washer method. And that's how you rock calculus!